All right, so we're going to look at today a difference of squares. Now, one thing particular with difference of squares is they're always going to be a couple of things. They're going to always be a binomial, which is something we haven't factored before. And they're also always going to always be subtraction. So no addition. Okay. And so we have difference of squares. We're going to have something akin of a squared minus b squared, let's say. All right. And this is always going to factor, it's a formula pretty much. And it is going, you want to look at, first of all, the square of the front, the square of the back. These are both perfect squares. You want to see if there's subtraction in between. And this is always going to factor into a plus b, a minus b. Okay? So whenever you have a difference or subtraction of squares, perfect squares on either side, they're going to factor into this format. When we go ahead and FOIL them, we get a squared minus ab plus ab minus b squared. And the middle two terms should cancel. All right, but if you have something like a squared plus b squared, this cannot be factored. This is something that we call prime. Okay, so difference means subtraction. So difference of squares factors, sum of squares does not. Now we're going to look at quite a few examples here. So example 1, x squared minus y squared. This is straight up from the formula. We're just changing variables. Right? This is going to factor into x plus y, x minus y. Okay? Because both the front and the back are perfect squares. However, example 2, we have x squared plus y squared. This one is going to be prime. This one cannot be factored. Okay, so if you forget the word for it, just write cannot be factored. All right, example 3 actually has some numbers here. So we want to look, first of all, are the front and the back perfect squares? Okay, well, a squared is a perfect square, is a squared. And 9 is a perfect squared called 3 squared. Remember, because 9 is 3 times 3. And there is subtraction in between, so it meets my requirements. Okay, so we use our bases when we have numbers. Okay, and this is going to factor into a plus 3, a minus 3. And if you check this, you will see that it goes ahead and works out. All right. Example 4, we're going to go ahead and look at it. We have a perfect square in the front, which is x squared. We have a y squared in here, but the problem is 3 is not a perfect square. Okay, so this one does not factor. So make sure that you're making sure that your number, just because it's subtraction, does not mean that your number is a perfect square. Everything in the front and everything in the back of that binomial has to be a perfect square. Example 5, we have 5n squared minus 125. N squared is a perfect square. 5 and 125 are not. However, this particular problem has a GCF, which, remember, is always our first step in factoring. Okay, so remember, if we have a GCF, we should first factor that out. So 5 and 125 are both divisible by 5. I should go ahead and take that out. All right, which is going to leave me n squared minus 25, because remember there's 5 quarters in $1.25. N squared minus 25 is a perfect square. This is n squared minus 5 squared. And what's in blue factors into n plus 5. N minus 5, remember when we factor out a GCF at the beginning, that gets tacked on at the very end. All right. Example 6, we have 16m squared minus 9n squared. Okay, we have subtraction. This is good. 16 is a perfect square. It's 4 squared. M is a perfect square. It's m squared. 9 is a perfect square. It's 3 squared. And n is a perfect square. It's n squared. Perfect. So this is going to go ahead and factor into 4m minus 3n. 4m plus 3n. Okay, so you're using your bases as to way to go ahead and factor this out. All right, let's look at example 7. I totally encourage you also to work these out beforehand. All right, also 4 is a perfect square, 2 squared. X squared is a perfect square. 9 is a perfect square, b is a perfect square. So this one would be 2x minus 3b, 2x plus 3b. And make sure that you multiply and go ahead and check these out. Example 8, n squared is n squared, 25 is 5 squared, but there's a plus in between. This one is prime, this does not factor. Okay, so go ahead, work on the practice problems. We'll be looking also at perfect square trinomials, and see you in the next lesson.